Hello, it's Keith here, and this is lesson 21 of the simple series of my 68000 assembly programming tutorials. Now, last time we looked at creating a graphic on the screen using the fixed layer, which is a simple tile map, and we drew our Chibico and we had it moving around the screen and cropping as it went off the screen. But because the fixed layer is limited to 8x8 blocks and it can't really scroll around, then we couldn't get very nice, neat movement. But now we're going to be using hardware sprites, and look how smooth that is, and it is cropped as it goes off the screen. Now at the moment we've got it set up so that any unused sprites are being removed. But if I remove this clear unused sprites line here and I compile again, well, now you can see as the graphic goes off the screen, you'll see some sprites being trailed, because it's not just changing the position of the graphic so that parts of it go off the screen. As parts go off the screen and hardware sprites are no longer needed, they're being removed from the drawing. And so if I leave them on the screen, they are staying on the screen there. Okay, so we're going to have a look at the code here and we're going to see what has changed since last time. Now, what I'm not going to do is I'm not going to go into great detail on how the cropping routine works, because I've covered it before. So if you need to know about that, please see lesson 20 of the simple series. We covered that in great detail. We're just going to cover what has changed this time. Okay, so here is the new code. So what has changed if we look at do crop? Well, the main thing that's changed to do crop is we are now working in 16 pixel blocks, not 8 pixel blocks, and the reason for that is hardware sprites on the NeoGeo are always 16 pixels. So rather than 8x8 pixel blocks, we're now working at 16x16. You see some changes in the code here. Now, when we've got our sprite, as our sprite is going off the screen, we're going to be removing blocks, but we're going to need to change the draw position to adjust it so we get that smooth movement. So as we remove blocks, we're taking the bottom 3 bits, that's going to be 0 from 7, but this is logical units and there's 2 pixels per logical unit, so 0 to 7 is 0 to 14 or 15 if you will. So this is calculating the offset for the removed tile, and so this is keeping movement smooth as the sprites are being removed. So that has been changed there. We've got an averaging here, converting it to a number of hardware sprites. And some of the shifts have been changed as well. You can see here as well, again, we're having to shift relative to the number of hardware sprites here. But apart from that, not too much has changed. Now, we are going to be working in coordinates of pixels, but we're going to be working in a multiple of hardware sprites, so multiples of 16 when we're actually drawing our sprite. Now here is our draw player routine. We're still working in logical units for the parameters that are passed, so we're passing 2400 here. The first pattern we're passing here is 2600 in D7 here. When the do crop is executed, if the carry is clear, then there's something on the screen, and we're going to need to draw the sprite to the screen. Now what we're doing is we're setting the hardware sprite number to use for the first hardware sprite. So that's D5, is going to count that, and it's starting at number 0. We're using the first sprite first. Okay, now the first thing we're going to do is we're going to convert our X and Y from logical units to pixels, so we're multiplying those by 2. What we're doing next is converting the width and height to a number of hardware sprites, so we're needing that to be a multiple of 16. So we're dividing those by 8 effectively, because logical units is 1 logical unit for 2 pixels, so we're shifting that to the right 3 times here and giving up if that returns 0. Now our routine itself is relatively simple. We're using this set sprite routine here, which is going to set a hardware sprite. I've used this routine before. It will just basically transfer the data into in the hard sprite VRAM to set a sprite up. So the X and Y position are going to be in D1 and D4, and the pattern number is in D7. And so we're setting 1 hardware sprite, and then we're moving across the screen by 1 unit here. We're moving the X position by 16 and moving the hardware sprite number and the tile number across by 1. We could use the vertical tiles more efficiently for the hardware sprites, but just to maintain compatibility with the other tutorials, I'm going across the screen and then down. So not using the hardware sprites as efficiently as they could be, but as I say, it's a lot of these tutorials are multi-platform, so it's about making things that work in a similar way on all systems. So we repeat until we've done 1 full horizontal line. Now after each line we need to add any tiles that need to be skipped. That's if our sprite is partially off the screen, then we will need to skip parts of it before we start drawing the next line, and that's what's happening here. And then we simply repeat for the next line. Now all of the work of actually setting up the sprites in VRAM is done by this set sprite routine here. Now the sprite settings are at memory address 8000 in VRAM here. So we are adding that to the hardware sprite number here, and then we're transferring the various parts of the data here. Now the various bits are at different memory addresses here, so it's a little bit of a pain calculating them. I have got a more detailed tutorial on the hardware sprites, and there's some documentation on my website. You can see here I've got a variety of data on the NeoGeo page. We've got a sort of chart here representing all of the data and the various memory addresses that data is contained at. So lots of different sections you're going to need to set. As I say, I tend to use this set sprite routine as a simple way of just setting basic sprites up. But if you need to do something more detailed, you're going to need to change the code accordingly. Now, once we've drawn our Chibi code to the screen, we need to remove any unused sprites. And we've got this clear unused sprites routine that will do this. And all it does is it simply goes through the first 9 hardware sprites. And it will use D5 as it was set by the previous routine. The routine will return with the last hardware sprite number in D5. And it will just continue through any others up to sprite 9. And it will move them to position 255 by 255 using the set sprite routine. And this basically just removes them all from the screen. And then once that's complete, it just returns. And that takes away the spare sprites so that we don't get that trailing appearance that we had before. Anyway, you can go to my website, you can download today's example, and you can also download the Sprite editor that I used to create the sprite graphic, export my Chibi graphic in the correct format for the hardware sprites. If you've liked what you've seen, please like and subscribe. I've got more tutorials planned on the 68000 NeoGeo and in general, so if you want to see more, please make sure you follow along. If you liked what you've seen, go to the website, download the source code and the build scripts and all that lot, and have some fun with it. As I say, you're welcome to use my code in any way you manage to benefit from it. Anyway, I hope you've enjoyed what you've seen today. Thanks for watching, and goodbye.